Hi everyone, I am Sailee Pawar and my presentation topic is JPEG 2000, which is still image compression standard, and here we are going to discuss why there is need for the another standard, though there is JPEG as a still image compression standard is available. What are the application areas and their requirements? What is the architecture overview of this standard, features of the standard, and then conclusion. Now, what is image compression? The compression techniques are used to reduce the redundant information in the image data in order to facilitate storage, transmission, and distribution of images. The basic concept of image and video compression is redundancy removal. The types of the redundancy can be classified as spatial, temporal, statistical, and visual redundancy. By some mathematical algorithm and human visual system characteristics, the digital image and video information can be manipulated and represented in a more compact way. That is what digital image and video coding does to shrink the data size. Now, why there is need of the another standard? The low bit rate compression. The JPEG offers an excellent quality at high and mid bit rates. However, the quality is unacceptable at low bit rates. For example, 0.25 bits per pixel. Now, the JPEG 2000 offers the performance superior to the current standard at the low bit rates, that is 0.25 bits per second. This is suitable for the applications like network image transmission and remote sensing. Second, the lossless and the lossy compression. The JPEG cannot provide the superior performance at lossless and lossy compression in single code stream. It is desired to provide the lossless compression naturally in the course of progressive decoding. The example of the applications that can use this feature include medical images where loss is not at all tolerated, image archival applications where the highest quality is vital for preservation but not necessary for the display. The next is the different types of the still images. The JPEG was optimized for natural images. Its performance on computer generated images and bi-level images is very poor. It is desirable to consider robustness to the bit errors while designing the code stream. One application where this is important is the transmission or wireless communication channels. The portions of the code stream may be more important than the others in determining decoded image quality. The next is large images. The JPEG does not compress the images greater in the size of 64 x 64K without tiling, and the single decompression architecture. JPEG has 44 modes. Many of them are applicable, application specific, and not used by the majority of the JPEG decoders. Now, what is the JPEG 2000? JPEG 2000 is a new compression standard for still images intended to overcome the shortcomings of the existing JPEG standards. The standardization process is coordinated by the Joint Technical Committee on Information Technology of International Organization for Standardization, that is ISO, and International Electro-Technical Commission, that is IEC. JPEG 2000 makes use of the wavelet and subband technologies. The core compression algorithm is primarily based on the embedded block coding with optimized truncation, that is EBCOT, of the bit stream. The EBCOT algorithm provides a superior compression performance and produces a bit stream with the features such as resolution and signal to noise ratio, scalability, and random access. The JPEG 2000 targets. Now, the JPEG 2000 coding standard is the standard for different types of still images like gray level, color, multi-component images, then different images with the different characteristics like the natural, scientific images, and different imaging models, client server or the real time, within a unified and integrated systems. This coding system is intended for first, low bit rate applications exhibiting rate distortion and subjective image quality performance superior to the existing standards. Now, what are the applications of the JPEG 2000? This JPEG 2000 standard provides the set of features that are of importance to many high-end and emerging applications by taking the advantage of the new technologies. It addresses the areas where the current standard failed to produce the best quality or performance and provides capabilities to markets that currently do not use compression. The markets and the application better served by the JPEG 2000 standards are internet, color facsimile, printing, scanning, digital photography, remote sensing and e-commerce. This shows the JPEG 2000 encoder and the decoder block diagram. In case of the JPEG 2000 encoder block diagram, which consists of the three important blocks, which are the forward transform, quantization and entropy encoding. In this, we are giving the source image data as an input to the encoder, and we are getting the compressed image data at the output that can be stored or that can be transmitted. And in case of the JPEG 2000 decoder, we are applying the input, that is the compressed image data, to the decoder, which consists of the three important blocks, that is entropy decoding, dequantization and the inverse transform, and at the output we are getting the reconstructed image data. At the encoder, the discrete transform is first applied on the source image data. The transform coefficients are then quantized and entropy coded before forming the output code stream, that is bit stream. The decoder is the reverse of the encoder. The code stream is first entropy decoded, dequantized and inverse discrete transform, thus resulting in the reconstructed image data. Although this general block diagram looks like one of the conventional JPEG system, there are radical differences in all of the processes of each block of the diagram, and these are: the source image is first decomposed into components. The image components are decomposed into rectangular tiles. The tile component is the basic unit of the original or reconstructed image. A wavelet transform is then applied on each tile. The tile is decomposed into different resolution levels. The decomposition levels are made up of the subbands of coefficients that describe the frequency characteristics of local areas of the tile components rather than across the entire image components. The subbands of the coefficients are quantized and collected into the rectangular arrays of the code blocks. The bit planes of the coefficients in a code block are then entropy encoded. The encoding can be done in such a way that certain regions of interest can be coded at a higher quality than the background. The markers are added to the bit stream to allow for error resilience. The code stream has a main header at the beginning that describes the original image and the various decomposition and coding styles that are used to locate, extract, decode and reconstruct the image with the desired resolution, fidelity, region of interest or the other characteristics. Now we can decompose this whole compression engine into the three parts, that is the pre-processing, the core processing and the bit stream formation. In the pre-processing part, the image styling, the DC level shifting and the component transformations are included, and in the core processing part, which consists of the discrete transform, the quantizations and the entropy coding processes, and finally the output code stream is formed. Now in case of the pre-processing, what is the image tiling? The term tiling refers to the partition of the original image into rectangular non-overlapping blocks which are compressed independently as though they were entirely distinct images. All the operations including component mixing, wavelet transform, quantization and entropy coding are performed independently on the image tiles. The tile component is the basic unit of the original or reconstructed image. Tiling reduces the memory requirement, and since they are also reconstructed independently, they can be used for decoding specific parts of the image instead of the whole image. Now the DC level shifting. Prior to the computation of the forward discrete wavelet All samples of the image style component are DC level shifted by subtracting the base quantity, that is 2 raised to p minus 1, where p is the component's precision. DC level shifting is performed on samples of components that are unsigned only. Level shifting does not affect variances. It actually converts an unsigned representations to the 2's complement representation. Now in this figure we can see that the tiling, the entire image is divided into the 4 rectangular boxes, and in case of the effect of the tiling that is shown on the image quality, without tiling we get the good image quality, and as tiling size reduces, that is the smaller tiles, the image quality gets degraded. Now in the pre-processing, the second part is the component transformation, which maps the data from the IGB components to the Y, CR and the CB components, which are less statistically dependent and compress better, which serves to reduce the correlation between components, leading to the improved coding efficiency. There are 2 types of the component transformation, that is reversible and the irreversible. The component transformations improve the compression and allow visually relevant quantization. Now there are these 2 different component transformation, which is one is the irreversible component transformation that can be used for lossy coding, and one reversible component transformation that may be used for lossless and for lossy coding also. In case of the forward and the irreversible wavelet transform, the forward and the inverse ICT transformation, which can be achieved by the formulas as shown in the slide. And in case of the reversible component transformation, it is a decorrelating transformation which is applied to the 3 first component of an image. The 3 goals that are achieved by this transformation is the color decorrelation for efficient compression, reasonable color space with respect to the human visual system for the quantization, and the ability of having the lossless compression. The forward and the inverse RCT is performed by means of the formulas as given in this slide. Now the ICT example is as shown in the figure, where the original image, that is consisting of the RGB components that are that undergoes the irreversible component transformation to produce luminance, chrominance and the chrominance CB and the chrominance CR signals. Now the wavelet transform. The transform coding is to transform the image data from the spatial domain to the frequency domain. After the transformation, there is an advantage of signal energy compaction, which is better for data compression. Also, the HVS, that is human visual system characteristics of the sensitivity on the different frequency components, can be used for the quantization. In case of the JPEG 2000, which use the discrete wavelet transform, the 2-dimensional discrete wavelet transform is a series of low pass, high pass filtering and subsampling in both the horizontal and vertical directions. The spatial domain data are transformed into the LL, that is horizontal low pass, and vertical low pass HL, that is horizontal high pass, and vertical low pass LH, horizontal low pass and vertical high pass, and HH, that is horizontal high pass and vertical high pass subband signals. In the frequency domain, in image coding, mallet structure is usually adopted, that is the LL subbands in each resolution can be further decomposed into 4 subbands. As we can see in the figure, the 2-dimensional discrete wavelet transform data flow and the result of the image after the DWT of the 2-level decomposition is as shown in the figure. The second operation of the core processing is quantization, which is the main scheme to control the compression ratio. Lossless compression can only be achieved limited compression ratio. By quantization, the range of compression ratio is widened and can be adjusted by specifying different quantization extent. JPEG 2000, a specific quantization step can be defined for each subband. After the quantization, the entropy encoding is used. The statistical redundancy can be removed by entropy coding. It is a lossless coding process based on the concept that more frequent symbols can be assigned the shorter code words and the less frequent ones can be assigned the longer code words. The average code length of the variable length coded data will be therefore shorter than the fixed length codes. In case of the JPEG 2000, the arithmetic coding is used. After the coding, we perform the bitstream organization. In the bitstream organization, the compressed data from the bitplane coding passes are separated into packets. Then the packets are multiplexed together in an ordered manner to form the one code stream, that is the output bit stream. Now, in case of the decoding, as we have already discussed, which is the opposite of that of the encoder, the code stream is received by the decoder according to the progression order stated in the header. The coefficients in the packets are then decoded and quantized, and the reverse ICT is performed. In case of the irreversible compression, the decompression results in the loss of data. The resulting image is not exactly like the original. Now, these are some characteristics which are given by the JPEG 2000 standards, that is compress once and decompress many ways, the region of interest encoding, scalability, and the error resilience. Now, in case of the compress one, decompress many ways means in JPEG 2000, the compressor decides the maximum resolution and maximum image quality to be used. It is also possible to perform random access by decompressing only a certain region of the image or a specific component of the image. Both can be performed with varying qualities and resolution. In each case, it is possible to locate, extract, and decode the bytes required for the desired image product without decoding the entire code stream as shown in the figure. Now, the ROI, which is the region of interest. The functionality of the ROI is important in the applications where certain parts of the image are of the highest importance than others. In such a case, these regions need to be encoded at the higher quality than the background. During the transmission of the image, these regions need to be transmitted first or at the higher priority. The third one is the scalability. The scalable coding of the still image means the ability to achieve the coding of more than one qualities and resolutions simultaneously. The scalable image coding involves generating a coded representation in a manner which facilitates the derivation of image of more than one quality or resolution by scalable decoding. The bit stream scalability is the property of a bit stream that allows decoding of the appropriate subsets of the bit stream to generate complete picture of required quality and resolution. Now, the error resilience. The error resilience is one of the most desirable properties in the mobile and internet applications. The JPEG 2000 uses the variable length coder, that is arithmetic coder, to compress the quantized wavelet coefficients. The variable length coding is known to be prone to the channel or transmission errors. A bit error results in the loss of synchronization at the entropy decoder, and the reconstructed image can be very damaged. To improve the performance of transmitted compressed image over the error prone channels, the error resilient tools are included in the standard. Now, as shown in this slide, we can see the difference between the image which is compressed at the 0.125 bits per pixel by means of the JPEG and by means of the JPEG 2000. In case of the JPEG 2000, we get the cleared image as shown in this slide. Now, in conclusion, we have seen the lossless and the lossy compression higher image quality and compression ratios as the advantages of the JPEG 2000. The JPEG 2000 uses the wavelet technology to compress images, that image being compressed more efficiently. Currently, JPEG 2000 uses the one wavelength for lossy compression and another wavelet for the lossless compression, but in the future other wavelets may be used as the need arises. The many applications that we have seen, including the internet, medical imaging and digital photography, overall the JPEG 2000 is a huge upgrade over current compression methods and looks to be the next image compression standard in the near future. Thank you.